Hello everyone, this is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University-Surampalem. In this lecture, we will identify the conditions for the correct steering in a steering gear mechanism and we will study about the Davis steering gear and Ackerman steering gear. The learning outcome for this lecture is at the end of the lecture, student can explain the conditions for the correct steering. So, here fundamentally we need to know about where we are using the steering. So, everybody know the steering gear, the steering is for 4-wheel drive. Okay. So, this is actually the vehicle is turning in a arc. Okay. Either it is the left turn or the right turn, whatever it might be. Suppose the path is in a straight way, the driver need not change the steering, right, either to the left or right, okay. Automatically it will go straight. Whenever there is a left turn or the right turn, then only the problem will come to the design for the steering gear mechanism, right. So, whenever we are turning to the left or right, automatically there is a difference between the rotation of the wheels, inner wheels and outer wheels. Now, what is inner wheel, what is outer wheel? Actually, the vehicle will have 4 wheels, right? Suppose I am writing like this, okay. So, in this, suppose this is my wheel, 4 wheels are there. Now, I am showing the top view, right? So, suppose I am going in a straight way, right? So, these two are front wheels and these two are rear wheels. So, I do not know left tire is the inner wheel or the right tire is the inner wheel, I do not know, right, until I decide whether I need to rotate to the left or right. If I am rotating to the left side, okay, so here you can see I am rotating to the left side, right. So, whatever the wheels that are very close to this arrow, that means this one and this one, right. These two are inner wheels, these two are outer wheels. Just to remember, I need to rotate like this, okay. Now, what is the radius of the circle? So, this is R1 and this is R2, right. Now, you can identify very clearly what is inner circle, what is outer circle. This is outer circle and this is inner circle, right. So, the wheel which is on the inner circular arc, that is inner wheel 1, inner wheel 2. So, we are having 2 inner wheels, one is at the front, one is at the rear side, okay. So, these two are outer one. Now, what is actually the problem for the steering is, whenever we are turning in a circle, just look at this, we are having a circle here, right, we are having an inner circle here, okay. Now, suppose I am having 2 points here, this is point P, this is point Q, right. If I am turning through some 90 degrees, let it be 90 degrees, okay. So, I am moving to P1 and Q1, right. Now, look at this 2 circles very carefully. The distance from P to P1, the distance from the Q to Q1, are they equal? No. P1 is lesser one and Q1 is higher one, right. So, this PQ, but you remember PQ are attached, What is that attachment? Inner wheel and outer wheel of the front side, right. This is P and this is Q. So, P has to move to P1 and Q has to move to Q1. This is I am saying for only a small turn, right. If this is a very small turn, no problem at all. In the middle, there is P dash and Q dash. Whatever it might be, the arc of movement in the inner circle is definitely lesser than the arc of movement from the outer circle, right? Because the radius is more, automatically r d theta will also be more, right? So, r1 d theta is lesser, r2 d theta that is more. So, definitely the outer wheel has to travel more distance than inner wheel, but remember the P and Q are attached. How can we make in a particular circle, whenever the circle is moving like this? Suppose, look at this, my hand, this is P and this is Q. While I am traveling on a road in a circular way, how can I make such that the P has to move lesser distance and Q has to move higher distance, right? So, this is the way we need to go for steering gear mechanism, right? So, we need to arrange the links in such a way that I need to have the P has to travel lesser distance and Q has to travel more distance, right? So that the vehicle will be in correct position. Now you can observe whenever you are having a turning, right? So you look at this, these wheels and these wheels. What is the moment? Okay. So the inner wheels movement is different, outer wheels movement is different, right? Either it is the left turn or the right turn. So this is actually wheel number 1, wheel number 2. So this is the wheels are being attached through a link and we are having the tie rod. Whenever you are having the moment, automatically due to the moment given to one wheel, automatically it is being transferred to the other wheel. So this is turning through some angle, automatically it is tilting the tie rod and wheel fix link. Now you can see this. Now what is the condition for the correct steering? So correct steering means the vehicle should not forward turn, right, or it should not skid, right. Now the condition for the correct steering is actually the instantaneous center I. Already we know what is the instantaneous center. In the first unit of the links and mechanisms, we know that the perpendicular from wheel number 1 and wheel number 2. Earlier we are having link A, link B like that. Okay. So from link A perpendicular line and link B perpendicular line. So when they met together in a particular point, it is called instantaneous center. So in this case, now look at the diagram. This is the inner front wheel and this is outer front wheel. Now I am making left turn, right. So in my left turn, this is turning through some angle theta, right. Now this is turning, the outer front wheel is turning through phi angle, right. Both the angles should not be the same because inner wheel traveling distance, outer wheel traveling distance, both are not same, right. Okay. Coming into this, the dimensions, the distance between the wheels is A, the distance between the front wheel axle and the rear wheel axle or back axle, that is small b, right. Now the tie rod distance, axle distance is small c, okay. So one angle is theta and one angle is phi. Now the condition for the correct steering, in order to avoid skidding or slipping of the wheels sideways, the two front wheels must turn about same instantaneous center, which lies on the axis of the back wheels. This is actually the condition for the perfect steering or correct steering, we can call it as, right. So the instantaneous center must lie on where it should be, in the line of the back axle, right. So it might be here or it might be here or it might be here. So if it is on this line, it is safe for the vehicle. So the condition for the correct steering is that all the four wheels must turn about same instantaneous center, right? Now you can ask one question, what about the instantaneous center for the back wheels, right? Already these two are on the same line and instantaneous center is also on the same line. So perpendicular will pass through this, for this perpendicular for this through I only. So all the four wheels will have same instantaneous center. Now we will identify the mathematical calculation how I will get the correct steering condition. So the axis of the inner wheel makes a large angle theta, then the angle phi subtended by the angle axis of the outer wheel. So a distance, the distance between the wheels, we call it as wheel track, and b, that means the distance between the front axle and the rear axle, we will call it as wheelbase. And what is the c? Distance between the pivots a and b of the front axle, that is actually the distance between of the tie rod. Okay. Now by using these two, we will identify the correct angle, right? How to get this correct angle for the steering condition, right? In this, we will calculate what is tan theta. It is b. Actually, we need to identify some triangles IPB right angle triangle and IPA right angle triangle, right? So in this IPB, so this is theta and this is B and this is PB. Okay. What is tan theta? Opposite side by adjacent side. So this is small b divided by PB. Okay. Now what is next to right angle triangle is IPA. This angle is phi. This angle is phi, right? Now I am calculating tan phi is equal to, what is tan phi? IP by AP. So what is IP actually? Small b by AP. Okay. But for getting the condition, we are having, look at your PBA, right? PBA. We don't know what is PB, how much it is, but we know what is AB, small a. So I need to identify the relations of the tan theta, PB, phi something in terms of AB, AP or PB, right? So I need to get AB is equal to AP minus BP, right? Okay. What is AB? Small a is equal to, what is AP? Here AP from second equation. So I am writing, this is first equation, this is second equation. From the second equation, what is AP? If you come to the left side, AP will become B by tan phi, right? That means B cot phi. Okay. B cot phi. Got the point? Okay. Minus, what is BP? It is, now BP is coming this side and tan theta is coming on the opposite side. So this will become B cot theta, right? Now you can identify AB on the one side. Okay. Now you can get your answer very easily. A is equal to B into cot phi minus cot theta. So the condition is cot phi minus cot theta is equal to A by B, right? Is it clear? Now this is the condition, cot phi minus cot theta is equal to A by B. What is A? The distance between wheels. What is B? The distance between the axles, right? So AB already in your control. in your control, right? Now you need to identify some combination how to make your phi and theta should be satisfying this condition. So this is the condition for your correct steering. So at the end of this lecture, student can explain the conditions for the correct steering.